we're talking about WebRTC Reborn today. You're going to see a definite theme to the slides. Go with it. So I'm Dan_Jenkins on Twitter. Feel free to follow me, tweet me, increase my follower count. That's all good. So I'm a Node.js developer. I love Lego. I love Lego quite a bit. I'm a general geek. I'm quite proud of it. And yeah, I started my own company just over 2 years ago called Nimble. And I love, love, love open source software. It's what makes everything work. So I'm a Google developer expert in web technologies, but more specifically WebRTC. There's my GitHub. No one really finds that interesting. There's my Twitter. So just go back, tweet. Okay, so Nimble. There's some more information. Let's move on. So yeah, Nimble does Node.js consulting, WebRTC consulting, VoIP, anything real time. It's good fun, and what's the point in being anything but real time? So WebRTC. Who has heard of WebRTC? Good, we're in the right track. Who has built something with WebRTC and it's in production today? Okay. Who's used WebRTC at all? Okay, I'm going to rephrase that question a little bit. Who's used Hangouts? Okay, so pretty much the whole room, for the video, the whole room's hands went up for Hangouts. So built with WebRTC, so there's appear.in, Facebook Messenger, Hangouts, Slack now has it, Wire, Screen Hero, and Amazon Mayday. They all use WebRTC. So let's go back to that question. Who has used any of those products? So it's pretty much everywhere now, and it's being used by production people with a lot of traffic. So for all those people that don't know what WebRTC is, because there were a few of us that don't, WebRTC stands for Web Real-Time Communication. So RTC has been around for a very, very, very long time, but the web bit has been missing. It's secure by design. You cannot have a non-secure WebRTC session. And it's peer-to-peer, which means we're able to connect from one device to another with nothing in the middle of it. Within WebRTC, there is a media channel for audio and video, and a data channel for pretty much any kind of data you want to send down the pipe. In the JavaScript APIs, I'm not going to talk about native in this, because I love the web. Hopefully you'll understand that by the end of this talk. I love the web, and so I'm a web developer. And so I'm going to talk about web and why there's very, very little reason, really, to go down a native route. So there's Get User Media. Get User Media is designed to be able to get you access to that webcam, to the microphone, to screen sharing. It's asking for permission to use those devices. There's RTC Peer Connection, which allows you to create that one-on-one connection to other devices. And then within the peer connection, you can then create a data channel using RTC data channel. So in peer-to-peer communication, we've got a one-on-one relationship there. But how do you instantiate that call, that session, between those two peers? I mean, when I first learned about WebRTC, no one really explained this to me. And it's not really magic. Even though I love magic. Harry Potter is great. But anyway. So yeah, there's a signaling server / kind of protocol in the middle. So in this diagram, there's two peers, and then there's something in the middle, and we're using that signaling server to kind of create those that two-way communication. One way sends an offer, the other way sends an answer. They share some information, and hey presto, you've got this peer-to-peer two-way connection. So you can have two peers, you can have three peers, and this is what we call a mesh network. where each peer is connected to each other. Or you can have as many peers as you want. This is still a mesh network. And this is entirely valid. You can have every single peer connect to every other peer, and that's fine in some situations. Like, you wouldn't send audio and video to every other person in that scenario, but you might send data, and that's entirely fine. And there are no plugins. There are no plugins in WebRTC. This is kind of the big thing. This is what was talked about like 5 years ago. Oh, look, there's no plugins. But today we still require like extensions for screen sharing. It's kind of seen as a security mechanism. It's a bit of a shame because it kind of dilutes messaging and it makes things a little bit harder. But there are no plugins, there's no Flash, etc. But the most important thing about WebRTC is it opens the door for awesome. So it's an open technology. Google open sourced it, I think, coming up to 5 years ago. And now there are lots of contributors into it, and it's developed in the open, like, Google will develop something and then they'll open it. But the key thing is it's in browsers and it's in mobiles and it can be in any kind of device. As long as that device supports like the WebRTC implementation, then you can have it in any kind of device, whether or not that be like a really low-powered chip that's embedded into something, or whether or not that's your smartphone, or whether or not that's your browser in your high-end iMac. And we're able to communicate using the same set of protocols within WebRTC. So I talked about a low-powered chip. So this is a Lego Mindstorm. So a friend of mine called Tim Panton made this Lego Mindstorm into like a little dog. And so you can see on the front it's got some IR eyes and it's got motors. But the really cool thing is the brick, the EV3 brick, is flashed. And it runs with Java. So Tim wrote his own WebRTC data channel implementation in Java to fit on that device. So he's able to control that device. He can drive it forwards and backwards, and he can tell it to play a sound file, etc. All using WebRTC, and it's entirely peer-to-peer. I mean, it's completely useless, like completely and utterly, but it's really cool. Like, I get really fed up with like when you go to conferences and you see demos with drones and they're sending video, but it's all going via a relay and it's actually connecting up via something else via a MacBook. But this is actually true. This is actually someone's device, a mobile phone or whatever, connecting directly to that device, and it's powering that device. It's telling it what to do. On that, like, it's got a ridiculously small amount of RAM, and it's got a ridiculously small amount of processing power, but it's still running WebRTC. So, I'm a web developer. I love the web. I think we can scale things in the web much easier than what we used to be able to do in legacy type systems with like older media servers. But the web allows us to web scale. It allows us to utilize tooling that we've been developing over the past 10 years, and we're actually able to develop and deploy things in web scale. And there's a very, 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 very small dependence on media servers. So I talked about, like, before we would have media servers. And every call that you would make using Flash or Java or whatever, and it would go via a media server of some description. Like, it might end up going out via the PSTN, via a phone line or whatever. But there was a server there. And so you, as a maintainer of that system, you would have to have a media server. And if you wanted to be able to handle however much traffic, you needed to have however many media servers up. So WebRTC is mostly peer-to-peer. So we've got very, very, very small reliance on media servers. What that means is it's actually easier to launch your product quicker, because it's actually a lot easier to figure out what kind of amount of traffic you're actually going to need a media server on, what we now call relay servers in the WebRTC world. So awesome apps are being launched using WebRTC, and I don't really want to talk about businesses and how WebRTC can be used to make billions of dollars or whatever. Like the Amazon Kindle is a great example of a business using WebRTC in a really good way. Mayday allows the Amazon contact center person to be able to access your information and contextually, and you can see the screen, and hey presto, it's really, really good. But wouldn't it be really cool if we can use technology to help humanity, to make the world a better place? And people are doing that with WebRTC today. So there's an app called Be My Eyes. So runs as an app on your iPhone, and you can download it today. And as someone that can't see properly or entirely or isn't able-sighted, you can download this app and you can request access. You can request for someone to help you. Someone on the other end that can see says yes, and hey presto, you've got this peer-to-peer connection between the two devices, and that person, that able-sighted person, is able to help that person that isn't able-sighted. I mean, all of us that can see may think this isn't huge, but to anyone that isn't able-sighted, this is huge. Like, this is being able to get someone at almost any time of the day, because we live in a 24-hour world, and you're able to say, you're able to get someone to describe what something looks like in front of you. That's so special, and something we take for granted for people that can see everything. So MindMe is an app that's been around for, I think, just under a year. It was an app commissioned by the CDC in the USA, and it's powered by a company called Candy, Genband, who do WebRTC stuff. And what MindMe is all about is it helps people that are contemplating suicide. So there's a link down the bottom, and it will tell you an awful lot more about what MindMe is, and some really great stats on the number of people this app helps. So what this does is it puts someone in direct connection with a trained professional, be it a psychologist or someone, and when someone is feeling down and contemplating suicide, they can connect with someone one-on-one, completely free, like there's no phone call involved. There's video involved, and so like there's this connection. Like, I make a connection with all of you looking into your eyes that I don't get when I'm talking to you on the phone. And so MindMe is there to help people that are contemplating suicide. And I think that is truly amazing, and it's an amazing use of the technology available. Australia. So there's telehealth in Australia for cystic fibrosis. So Australia is pretty massive, even though it doesn't actually look it on the map. It's pretty massive, and there are vast spaces in between, like decent healthcare, etc., and people with specialized areas. And so WebRTC is helping people with cystic fibrosis connect with a specialist who is usually a 3-hour drive away. And so again, for all of us that are not ill and think, oh, driving 3 hours, like, oh, that's not an issue. Well, imagine having a debilitating disease that really affects you day to day, and you've got to take a 3-hour drive to get to that help. Whereas WebRTC is enabling us to do this like within minutes. That's pretty amazing. And the reason why, sorry, to come and double track. So the reason why this is amazing is because we're able to do it at a far less cost and in a bigger amount of, to a broader amount of people. So we can have native apps and we can have browsers, etc. And so people are actually able to access these things much, much easier. Cancer. So cancer telehealth in Texas. So this was actually developed by Bluemix and Twilio last year in about September, I think, or August. And again, it's exactly the same thing. People were having to travel hours to be able to get to a cancer specialist. Those hours are very, very important to someone with cancer. So now we're able to get those people in contact with specialists, and we're able to actually send them more information. We're able to connect up other devices, and we're able to send heartbeat rates, etc., all over the internet using WebRTC. So developers are building apps that help humanity, and that's pretty special. Someone said something about Google I/O last week, and how it was very much aimed at solving problems that the elite have, or very few of us actually have in real life. And we could be solving issues that really affect so many people in the world. Why is Google not doing that? Well, Google is, to a point, within WebRTC. They're enabling other people to build these apps. So to get onto the crux of WebRTC Reborn, now that you've got a bit of an idea of what WebRTC is and what it's capable of doing. So I want to take you on a bit of a history lesson and why I think WebRTC is being reborn right now. So WebRTC is about 5 years old, just gone over 5 years old. And yeah, you always mess up the first child. I don't have kids, but like, I've got 3 brothers, so I kind of know. Anyway, so you always mess up the first child. You're learning. I've got a dog, like that counts. We messed the dog up quite, and if we got another dog, then you'd think that would be better. Anyway, so yeah, we messed up. And because it was the first kind of joining of the web and like proper voice and proper video, there were these 2 worlds. One world really understood this stuff, and another world really understood the web and what web developers wanted. And when they kind of came together, it didn't really go to plan. So at the start, yeah, everyone was really excited. Phil will probably know. So everyone went and talked about WebRTC at conferences. They were like, yeah, this is amazing. But hey ho, it caused some issues. So people went to conferences and said, look, Ma, no plugins. It's amazing. Like, I've got access to my microphone, I've got access to webcams, and I can put it in my browser, and we can replace Skype. But no. Some people might have said, and I'm not saying this was me, it's freaking awesome. The dude is added in there after the fact. So yeah, developers went and tried it, and they usually failed, quite abysmally, because we didn't really explain things. We didn't explain the complicated stuff. We didn't explain the fact that you needed a signaling server. We didn't explain what SDP is. We didn't explain what stun or turn was. We'll get back onto this, don't worry. So there are all these things that we need to be able to create a proper WebRTC app that works, not just in your browser. So yeah, so who went to a conference about 5 years ago, heard about WebRTC, went home and they made one web page that then talked to another web page in your browser. So you'd open up a tab, and then you'd open up another tab, and you'd get the two tabs to talk to one another. So I'm seeing nodding heads, yeah. And so you might upload those files, those static files or whatever, to a website, and you'd send a link to a friend, and it wouldn't work. You'd be like, damn, like, what have I done wrong? And you could never figure out what you did wrong. It's because people didn't tell you that you needed a stun server in this instance. It always worked locally, but it never worked when you wanted to go outside of your network. So yeah, we failed you. We failed developers. We didn't want to make it complicated because web developers weren't used to having this complexity. We wanted to make it really simple, and we didn't explain it enough. But that's all changed. Like, we're 5 years on, like, we've learned from our mistakes. Like, if we released another WebRTC today, we wouldn't make the same mistakes again. So, you might be wondering, like, the pig, why is the pig there? Well, how's the pig relevant? It's not. It's cute. So, why is WebRTC better now? So, we've got a really strong community in WebRTC. People at Google, people at Mozilla. We've got big companies really outside of the web community, really trying to make WebRTC better. There are a couple of alliances now around media, so it's really great. There are Google developer experts, so I'm one of them. Phil Nash is another one. There's two more, I think, in USA and Europe. And we're available to you. We want to help you. So there's a couple of other resources that are really mentionable. So there's WebRTC Weekly, and there's WebRTC Hacks. Both of these are like great resources for anyone wanting to, one, know about WebRTC, two, keep up to date with WebRTC. It used to be that probably about 6 to 12 months ago, it was a full-time job keeping up with WebRTC. And so back then I would have definitely told you, go and use a platform because like you can't keep up with everything because it's changing too much. And these are the places you would have gone to, probably. That's changed a little bit. I'll come on to that in a bit. But we've got excellent browser support now. So in the early days, it was in Chrome, and it was then in Firefox a little bit later, and the two didn't really work together. But hey presto, we've got great browser support today. We've got Chrome on desktop, we've got Chrome on Android, we've got Firefox, we've got Opera on desktop and on Android, and we've got Microsoft Edge to a degree. You'll see there ORTC, which is like a different version of WebRTC, but it's there. And the two can kind of interop with an adapter that Twilio made last year. It's not brilliant, like in terms of interop completely, but it is there, and it's moving in the right track. So who's missing? Safari. Safari on the desktop and Safari on the mobile. Yeah, this has been pretty sad, but there's hope. So last year, there was a project called WebRTC in WebKit, and it was run by a load of companies that care about WebKit, that use WebKit but weren't Apple, because there are lots of other people out there using WebKit today. And obviously it's open source, and so if you want something, go and do it. So Apple put an engineer on that project, and they committed code into that project to make Get User Media work in Safari. So this was great news, probably coming on to a year ago now. But more recently, this is really interesting. If you go to webkit.org/status, you'll see that WebRTC is now in development properly. So Apple are putting people behind WebRTC, sorry. And the great news is, I think the underlying WebKit is exactly the same on desktop and mobile. And so if one gets it, the other one should get it. Hopefully, we'll see at WWDC an announcement about this. I'm hoping I've been wrong about these things in the past. And Microsoft Edge. So Microsoft had a conference a couple of weeks ago called Edge Summit, I think, Edge Summit 2016. And they announced that they are going to support WebRTC. They're going to support WebRTC version 1, even though it's not actually version 1 yet. Going to support VP8, going to support H.264, and a few other things. But the key things there are VP8, H.264, and the WebKit proper APIs. So that's really great. Like soon, Edge will be able to interop completely without Twilio's adapter. Sorry, Twilio. And everything will just work, and it will be amazing. So all these supported browsers, their progress has been truly staggering over the past year, especially over the past year, probably. And since probably about September, we've been moving fast, and we haven't been breaking things. So we heard earlier in the keynote about moving fast, don't break things. And the browsers are now doing this. Well, hurrah! It's great. So yeah, before like September last year, they were moving fast and they were breaking a lot of things, and it was horrible. But yeah, the picture today is great. And like for the browsers that people to a point don't care about in this area is IE and Safari. There are plugins for that. Temesys have one. There are a couple others out there as well. And they all do a job to a certain level to get something working. Whether or not that's like the best user experience is debatable, but something is better than nothing. And if you really care, you can keep up to date with whether or not certain APIs are in certain browsers, and yet made this great website called isWebRTCReadyYet.com. Come back to me at the end of the presentation and I'll tell you the answer. But yeah, this will tell you like where are our levels of coverage within each browser, what does each one support. So we've talked about like how browsers have got better, etc. But the whole ecosystem has got better. So we've got simple signaling available to us now. So I'm a Node developer. I know Node, so I'm going to talk about Node. But there are lots of other languages out there, and there are great packages out there as well. But today you can go on NPM, the Node package manager, and you can say, go and install a particular signaling server, and hey presto, you've got a signaling server. You can use I/O, socket I/O, to give you a very, very basic one to send some raw data. And it's really, really, really simple. So I can't reiterate this too much. You need a signaling server. You need something in the middle, and that's not really talked about a lot. And I'll tell you why it's not talked about a lot. The signaling part is not part of the WebRTC spec. And so, sorry, draft, because it's not spec yet. It's not part of the draft. And so we always forget about it when we talk about things and we write blog posts, etc., to do with the WebRTC spec/draft, because it's not part of it. And that's great to a degree, but it's also not great. Like there's lots and lots of different versions that you can go with, and they all do different things, and they're all great at different things. But how do you pick one? Well, that's a problem. But there are lots and lots of them out there. So yeah, who knew? I don't know why that's cut off. Who knew you needed a signaling server? But yeah, there's open source signaling servers out there. Socket IO, which is based on Node. There's something called matrix.org, which allows you to do a load of other stuff, but you can use it. There's Asterisk. Asterisk is a telephony engine. There's something called Signal Master from And Yet. I could go on. There's loads and loads of them. Just Google open source signaling servers, and you'll come up with loads. But the documentation has got so much better in the past 5 years. Like, you can now go on sample webrtc.github.io/samples, and there's loads of code and there's loads of documentation. It's great, and there's like, it has real life examples and it shows you it working. It's great. So yeah, github.com/webrtc. There's also a code lab on Bitbucket. There's also a great website called webrtc-experiment.com. And this has like absolutely everything that you could ever do with WebRTC, and it has real life examples and real life code, run by someone called Muaz Khan. And all the code is on GitHub. So yeah, there's github.com/webrtc/samples for the actual code, or you can go to webrtc.github.io/samples to actually run that stuff in your browser, and it's great. For a load of other resources, g.co/webrtc, something that Sam Dutton at Google made. And then the last link is a proper code lab from Google that they point people towards to go through that, like to really learn WebRTC step by step. So I talked a little bit earlier about stun and turn servers. Who doesn't know what a stun/turn server is? Or why you would need one? Okay, so there are people in the room that don't know, and that's not surprising at all. Sorry. So stun. Stun is basically a mirror. You can go off to stun and you can say, what's my IP address? And it'll return with your public IP address. Fun fact, Siri doesn't make a good stun server. I tried this out. What's my IP address? Tells you your current address. So don't use Siri. Siri's good for a lot of things, but not as a stun server. So, and turn is what we call a media relay. Usually these two things are kind of piped up into a box together. They're the same software, they're in the same released code. And what turn does, or a media relay server does, is that red line there is a nasty corporate firewall. We hate nasty corporate firewalls, and we usually have to VPN in and whatever else. So a nasty corporate firewall is in the middle, and it's stopping a session. But what the media relay server does is it runs on ports that firewalls usually allow, and relays that media in between. So it's, to a degree, no longer peer-to-peer. You are still connecting peer-to-peer to that media relay server if you want to get technical. But it's no longer peer-to-peer between the peers. Anyway, so that's turn. So yeah, you've got more choice when it comes to turn and stun. There are Docker images out there. You can just run a Docker image. You don't need to understand how to necessarily run all this stuff, because like there are a lot of dependencies for these things. A remarkable amount of dependencies. So yeah, you can just run a Docker image now. There's loads of them. So yeah, don't forget, you need to address a stun server in your app. This is why our 2-tab app always failed as soon as you went outside the network, because we never addressed a stun server. And so you were never able to find out what your other peers' public IP address was. And so Google, nice people, they give you access to some. I know loads and loads of other companies do, because it's used within VoIP. So yeah, don't repeat history, use a stun server. So there's loads and loads and loads of modules on NPM. So go use them. Loads and loads of wrappers as well. So adapter.js is like the big main one. You should put this in every single WebRTC app that you write yourself. It kind of sorts out all the mess between the browsers. There's peer.js. I'm going to just rattle them off because there's loads. Easy.js, simple WebRTC, yeah, loads and loads. Again, Google them and they'll be there. But my big point is there are loads of platforms as a service. So you go and use them. Like, if you want to build something and see whether or not your users are going to engage and use the service, then what's the point in writing all this stuff and maintaining like all the behind the scenes stuff? Go use a platform. So Twilio, we're at Signal. I should probably put Twilio on its own slide. So Twilio is one of them. But there are loads and loads of other ones. Zura, which used to be Forge, which used to be Ascision, Candy, Talkbox, Respoke, Cisco, which used to be Tropo, but there's loads and loads and loads of other ones. Again, Google them. So some very, very quick stats. So there's 2 billion plus enabled WebRTC browsers in the world. And those 2 billion, those 2 billion are making 1 billion worth of audio and video minutes per week in Chrome. That's not including any of the other browsers. These are stats from Chrome. That's a lot. But there's loads and loads and loads of other improvements coming all the time. So ECDSA makes your initial startup time quicker. Opus 1.2 makes compression, etc. A lot better. Media Recorder. So Media Recorder in your browser is now able to record video and audio within the browser, and then you can do stuff with it. That's cool. H.264, so that enables you to talk to devices in a better way, like talking to a mobile phone that has H.264 encoding built into hardware. You're able to actually talk and use less bandwidth, less CPU. VP9 is a video codec. There's a Cocoa Pod for iOS coming out from the WebRTC team. There's tab sharing. There's Canvas streaming. So these have been added in probably the last 6 to 7 months. This is huge, like in terms of features and abilities. So you can go to that URL. I thought that was a little bit long, so I shortened it for you. So yeah, and soon we'll have a specification. It's currently in a working draft, but I thought it would be a spec by May. Well, we're now in May, so I was wrong. So yeah, public service announcement. And my clicker has decided to stop. Public service announcement. So Chrome now limits you to getting access to your webcam and microphone to trusted origins. So trusted origins include localhost and HTTPS. Big titles usually say HTTPS. That scares developers because they're like, how do I run this locally? How do I develop my app? Anyway, it's localhost plus HTTPS, but not self-signed certs. But with HTTPS, Let's Encrypt is here to save the day, and we're now able to access SSL/TLS certificates free of charge. So yeah, don't get caught out wondering why your app doesn't work. You go to a website on HTTP and it doesn't work, and you're like, why? It's because Chrome is limiting you. So it's time to give WebRTC another go. Is WebRTC production ready yet? Is WebRTC ready yet.com? Well, that website should have a big heck yes. Go use it today. Big companies are using it today. Go use it. And that's me. Thank you very much for listening.